Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. This episode is a conversation with Zach Denning, co-founder of analytics and advanced supervisory control software startup Hank, which was acquired by JLLT earlier this year. We talked about Hank's founding story, how the product works and how it improves control system performance, why JLL acquired Hank and how it fits into their broader product strategy, and how the Hank team approaches some of the challenges on the people side of implementing advanced supervisory control. So without further ado, please enjoy the Nexus Podcast with Hank co-founder Zach Denning. Hello, Zach. Welcome to the show. Can you introduce yourself?
Yeah, Zach Denning, head of product sustainability with JLL Technologies.
Cool. That's a recent role for you. Can you talk about start with your background, educational background, and how you sort of moved throughout the industry? You have a pretty diverse background. Can you talk about how you got here?
Yeah, a very new role. Yeah, so my background, mechanical engineering, and I always had a knack for software. So I did freelance in college, and I thought I'd get into the industry just doing something where I could combine the software with kind of my knowledge of mechanical engineering and HVAC. And so kind of stumbled into building automation. I really liked it. I liked the software side a lot. And I was always looking for opportunities in software. And I became fairly accomplished at the software side and kind of realized there's only like two paths in building automation to go. It's either you go into project management or you go into sales. And as much as I like the software, it's like, okay, I have to choose a path. And so I chose sales for a while. And it was very technical sales. A lot of times there's integration. So I was really setting up a lot of integrations. How do you connect to some legacy system on Windows XP? And so it was really value-driven integrations that I stumbled into. At that point, I got really good at them. Looked around a little bit, started doing some project management, spearheading my own projects. I started a controls division for a mechanical contractor that was very large out of the Bay Area in San Francisco, and started kind of looking at controls a different way, where we started looking at them as more like energy services projects, where we weren't focused heavily on, I think where the industry was headed was the hardware side. It's like, what hardware can we sell, and how is that hardware and CapEx going to generate a return? For me, it was, how do we implement the least amount of hardware, write the best software, and generate returns? I was able to partner with local utilities, get rebates, and then also partner with some third-party financiers to help finance the project. And we ended up with these great returns, a year less payback on 3 or 4 of these pilots that we ran. They were really awesome. Went to work for a OEM for a while, kind of learned that side of the business and partner channels and distribution, which was great. And then I brought it all together and started Hank. At the time, it was under a different name, but we really launched this premise that, you can take software and actually build a business around it in this industry, which I think is massively challenging. I think a lot of people have tried it, and it's gone, I'd say in some cases, very successfully for a lot of other companies. But my thing was always like applying machine learning. Can you take machine learning and can you actually apply it in the industry for more than just monitoring? Like, how do you get it to that kind of that next level? And so, I went out, I tried to sell analytics like everybody else, except mine was going to be, machine learning to generate an actual level 2 audit. Went out, tried to sell it, found that there's a very niche market that is willing to pay for that long-term over a SaaS product. And so kind of reeled it back in. I won a California Energy Commission grant. And the whole premise was, can we take this machine learning that we've really used for monitoring and analytics and apply it to a building? And not just in a way that it's doing little things. Can machine learning run a building? So can it tune and run the actual functioning systems of an HVAC system, lighting, whatever else we could really get our hands on and apply it to? And over the course of about a year and a half, we proved it was entirely functional. Not only that, it saves massive amounts of energy, and we stumbled across some huge breakthroughs with comfort, IAQ, where you can really expand on the industry and what it's done. So, grew it from there, commercialized, and, really grew it into what we know as Hank today.
Got it. And the acquisition happened when? A couple of months ago? Is that right?
Mm-hmm. Yeah. We were acquired late December, early January.
Okay.
By JLL Technology.
Can you circle back to what you were talking about with hardware versus software? How is the industry so focused on hardware? Can you explain that a little bit more? And then why is that?
Yeah. It comes from like traditional sense, right? Like you started with pneumatics in like the 60s, 70s, and it progressed into electronics and controllers and everything it was. And I think that it never really evolved outside of that. When we look at adjacent industries, you look at like, computers in the 90s. I think our industry is still stunted in the same way that IBM, Compaq, and a lot of these other companies, where it's the assumption that a vertical stack is still plausible in this industry. It works in some cases, there's no doubt about it, but I think that's company specific, not industry specific, and so I think they figured this out, and some people figured it out the hard way with, IBM and Compaq and some of those companies kind of learned the hard way. But you had, Windows and Dell, and I think Dell was a recognition that hardware, if you build, the cheapest, best hardware and you apply one singular software interface to it, you can build an entire stack separately. You can piecemeal out the stack. Mm-hmm. And I think that we're going to that distributed architecture is coming. I think a lot of people don't want it. I think a lot of people would like to say that it's vertically integrated and that everybody can do everything, but I don't think it's plausible. And I think that, in a lot of ways, the OEMs traditionally are still focused on hardware because that's what they've done. I noticed that 5 or 6 years ago, everybody's still talking about IP, hardware, and Ethernet in buildings, and you go talk to owners and they don't know what you're talking about.
Yeah.
And so the value delivery is very broken, I would say, between what our industry and building automation values versus what the end user, the true consumer of the product, which is the financial benefit, is perceiving.
Yeah, totally. Okay, so with Hank, you said, okay, let's develop this software layer that improves upon control systems. What were the improvements that you were hoping to make to a control system?
Yeah. So originally when we got in, it was, hey, we'll optimize it. We'll leave everything in place and we can optimize. And we did that. And we did it with some level of success, 5-10% total energy savings in buildings. And that was kind of like the Rev 1 or Alpha that we went after with the grant. And we proved in a couple buildings that, yes, you can do the traditional sense. And this is like akin to like maybe what like a building IQ would do, for example, in that sense that yes, you can get in and you can optimize set points. But what you find in the buildings, and this is always what's really interesting, is when you look at like autonomous car, for example, the car has to be able to drive successfully and efficiently from point A to point B, one stop sign to the next, effectively. It has to be able to, drive up the RPM, manage its miles per gallon, stop, brake. It has to do basic functions. Once it can do those functions, then the sensors necessary, which are already in buildings, to take it from Sacramento to San Francisco, for example, then that becomes a software problem. That's a machine learning problem. Now you're talking about tolls, speeds, traffic, all these factors of how do I get from point A to point B extremely efficiently. But I can't do that if I can't get from one stop sign to the next efficiently. And so what you learn in these buildings is you can't just optimize the top layer. You can't just grab the set points and say, hey, we're optimizing set points and you're going to save all this energy, because the underlying logic, the sequencing or subroutines, most of the time what we find is they're not optimized to work in the first place. Okay. So you have to start kind of at a base layer. You need to re-engineer the building, and then you can apply machine learning to the top of it with a lot of success.
Got it. What do you mean by re-engineer the building? Can you break that down a little bit further?
Yeah, so you already have the equipment in the building. You already have the building automation system. So you have all the control points, you have all the sensor readings, and you have the physical equipment in the space that's already doing something. But is that physical piece of equipment functioning in the proper way? And that's what we look at and say, no, it's not. Let's say the economizer is open before the cooling starts, right? You're not getting free cooling anymore. You're just engaging your compressors. And that's a sequencing issue. And traditionally, that's been tackled by design engineers. Design engineers come in and say, hey, we're going to redesign and retro commission it. They retro commission it. They turn it over to a building automation contractor. Mm-hmm. What we've done is been able to combine those two functions in Hank, where we have PEs on staff. We have engineers that can take a look at these systems and say, this is the best way the system should run. We actually rewrite our own sequences, and those sequences are interchanged or intertwined with machine learning. So not just in the sense of like supplier temp control, we're not just taking control of it and optimizing the machine learning. It's actually the machine learning gets more intertwined in the equipment, where maybe optimizing a VFD speed or something of that nature.
Okay. So whereas I think if we look at the rest of the industry, traditionally you might have a commissioning agent or a design engineer, like you said, come in and do retro commissioning. They might use an analytics tool like an FDD package, right? That might be a separate effort. And then you also might have So I call this advanced supervisory control, where you have a software layer sending supervisory control commands down to the underlying systems. You might have another vendor come in and do that. And you're saying, okay, this makes sense that we combine these two processes together in one software layer. Is that right?
Yeah, exactly. And I think that was part of, when we look at like the JLLT, the big vision is you have all these disparate tool sets. You have all these disparate services without a common outcome. And if they do have a common outcome, an owner, it's like so obfuscated for an owner of like, how many people do I need just to make my equipment work right? Right? Like when you look at software, right? This is the one thing with our industry I think is often missed, is it's still just software and it's still just technology, right? Our industry loves to believe that we're special, like building automation special because it's software and technology in buildings, and it's not. It's just software and it's just technology. I mean, you have tinkers at home playing with Raspberry Pis that sometimes, in some cases, have more functionality than what you would see in a multi-million-dollar Class A office high-rise, right? Where they're paying $100 per square foot, in annual leases. So when you look at it, we're actually a technology category that's significantly far behind the curve. And so when we look at like putting a project together, what we do, commissioning is technically just QCing in software. So what it's basically saying is the guy who wrote the software didn't write it properly, and a third party needs to come in with third-party tools, and they're paid separately to QC somebody else's software. All the while, the guy who wrote the software is getting paid to revise his software that didn't work in the first place. So it's a really weird industry. When you actually look at it from a 10,000 foot level, it gets really odd.
So let's break it down a little bit further in terms of what the product does. So typically, are we just talking about HVAC data? So we're collecting HVAC data primarily. Is that all the data is collected?
Anything we can get out of the building automation system. So traditionally, I would say like, half the buildings we work in have Windows XP on them still. So it's not like they're going to shade control anytime soon. I'd love it. I'd love if we got shade control projects, because then you have the whole idea of like, I can turn down, how much do I turn down the lights versus the shades versus the HVAC, right? And you get the BTU equations and it gets really sophisticated and fun. But, the average building in the United States doesn't even have CO2 control in it. So it's a lot of HVAC. And that's not to say though that, we've gotten into very advanced like chilled beam projects with slab heating, cooling, chilled beams, very sophisticated stuff that, we actually appeal to design engineers about, because they're like, you did what? And we start sharing data with them, and it gets very interesting as to the conclusions the machine learning makes on a day-to-day basis.
Okay. And then once the data is collected from HVAC, or primarily HVAC, what does it do with the data? And then what sort of commands does it send back down to the system, or updates does it send back down to the system?
Yeah, we're traditionally in full control of the building end to end. So I think that's a good place to start. Is everything is still running in the building how it used to, but we are overriding everything. So it is in full override, end to end override, and that is something to note. Is like we're functionally rewriting how the building operates almost every time. Now you can't do that in like a train package unit. You can't like take control of the compressors by any means, but for the most part, we get pretty deep into these buildings and pretty deep into the engineering. We do a lot of the normal stuff the analytics do. We take the data, we scrape the data, push it back to the cloud, run it through a digital twin. That feeds out, optimal running conditions, whether that be a VFD speed down to a set point, for example. So we do a lot of pretty in-depth machine learning. It's not just really high level. There might be some functional stuff that's just running standalone over here. That's just functional control or subroutines or SO. There's a lot of different names in the industry, but just functioning programming that runs actually on-prem on the edge. And then we have corrective actions usually come from the AI portion. The true machine learning portion is a lot of corrective actions. And those can be corrected down to like correcting the VFD speed if it doesn't make sense.
So it could be sequences, schedules, set points. I call them the 3 S's. You could modify any of those. You're taking full control of all 3. Okay.
It is a true building automation software replacement.
Yeah. Okay. What do you say about, I think there's this line of skepticism for these types of tools coming from what I would call like the controls geeks. That's basically, and I say geeks endearingly, of course, they say basically, I call it the diminishing returns argument. They basically say like, well, if the system were to be optimized the way it's supposed to be, then the system like this that sits on top of it, software like this that sits on top of it, machine learning is not really going to get us much else or much savings on top of that. What do you say to that argument?
Yeah. Yeah, it's an interesting argument. And I think it is one worth challenging. And I think in some ways it does have some significance, right? So I used to be one of the geeks who like got a hold of Title 24 sequence and would spend all night programming it. And then I wanted to understand it. Like, why was it written this way? And I have a few colleagues in the industry that I'd reach out to that are pretty close to the whole Title 24 scene. And I'd beg them for stuff. You know, even when I started this, it was like, what are you guys working on? You know, I want it in my platform, part of my functional program before it gets released anywhere else. We found we could deploy software a lot faster the way we deploy than traditionally. I don't have to wait for an OEM to produce an update that then I take. And so we can be 6 to 12 months ahead of the market a lot of time the way we deploy. We deploy a lot faster. And so I did it, right? And I think one of the things to recognize is in the industry and where it's headed is the sophistication of software is off the charts for what, one, is comprehensible by your average BMS programmer, and two, is incomprehensible to most building engineers and people that actually have to run the building. When you look at like the Title 24 spec as it was written 5 years ago, there's, over 600 different tuning set points in a 100,000 square foot building. 600. And that 600 split between localized controllers, so distributed controllers, and like an air handler controller and plant and rooftop controllers. That's 600 different tuning points, and none of them are documented. Of course, because like our industry doesn't believe in software, right? So it's all undocumented. You tune it however you want. And so everybody has their own way of tuning. I'll turn this knob and that knob, and there's 600 knobs, right? Imagine a board with 600 knobs, and I'm tuning all of them, and I say it's done, and I walk away. I used to do this. What'll happen is either somebody tunes a knob they're not supposed to, or the knobs tuning don't work for a different season, and I promise they won't. And you're going to have to come back and retune those knobs. But by the time you come back, somebody has tweaked those knobs so much for the current season that they don't even apply realistically for the next season. And so as a result, it goes off the rails, and you have to do retro commissioning or recommissioning or essentially just rebuilding software that was once built. And I think that's where the industry falls down in a lot of ways, is not recognizing the fact that everything has to be tuned. That's just the nature of the world. Especially with this kind of software, is it's static software. And the problem with static software, especially in this context, is it's tertiary systems that all rely on each other, that all have different tuning set points. And so it gets even more sophisticated. And so we look at projects less than 6 months post install, and we're able to drive 15 to 20% overall building energy savings. If you give me a building that's a month or two after, sure, it may drop to 10%, maybe 15. Okay, so maybe there's an argument there, right? But the way in which you look at equipment at different times of the day and how it operates differently, we're just not taking enough into account anyways from Title 24 or from HVAC operation in general to really encompass the entire energy gamut of what a piece of equipment consumes. I mean, you look at like, you have building pressure, that's an exhaust fan. You have supply fan pressure, that's the supply duct. You have supply air temp, that's the heating and cooling aspect of the equipment. You have all these different energy types that are all interrelated. And what people are trying to tell me is like, you've written enough code to understand all those, all these different conditions throughout the day in order to optimize.
Yeah,
it's not possible.
Yeah, I like to say to people that bring up that argument, like, show me that building, show me that building that's optimized, that doesn't need a software layer on top of it. Yeah, how many buildings have I been in and audited and crawled through the ducts of and looked through the BMS on, that have actually been at that point for a significant period of time? It's not very many.
Well, I'd say too, the other thing they have to look at too is like the long term, right? So we're not just like this optimization and control layer. Like, we offer full end-to-end support on the back end. That's all layered under a but a monthly fee, a fixed monthly fee. So you look at that too, and they say, well, why do you need software? Well, it's not just a software, it's a service, right? If any one of our engineers in our buildings call us and say, hey, I'm like 1 foot on a ladder holding on to a duct, and I'm looking at a unit right now, and I just need it opened. We open it for him. Not only do we open it for him, we tell him the reaction. We work with him as if we're an on-site engineer. So we've predicated our model on the fact that our software runs so well, you won't have software issues in your building. You'll have very, very minimal. You'll have so few that we can actually help you support all the mechanical issues in your building as well, which is something where if you go into that building automation industry right now and you look at some of the service contracts, do they offer hardware support? I mean, we have engineers calling us like, pipes burst, and they're like, what do I do? We have one guy where like the domestic hot water pipe burst on it. It's like pouring on him, and he goes, what do I do? And one of our guys is like, find the domestic hot water system. It's probably on the floor. It's probably in this closet. And he runs, and within 15 minutes, he has it shut down. And he's like, thank God I could call you guys. And I'm like, who else would he have called here? The BMS guy has no idea what he's talking about.
Right, right.
It's very interesting service.
Yeah, and I'm glad you pointed out the physical issues, right? Because a software that sits on top of a control system, it's only going to be as good as the physical components that it's commanding open or closed or on or off, right? So can you talk about like the value of fixing physical things for the software to work properly?
Yeah, absolutely. I think this is one of the things that, I learned early on doing like machine learning driven analytics. And again, it's applied. Like I never wanted to build something that was like fluff or not necessary, right? So like when I incorporated machine learning in, it was, can I go identify a problem before, can I look at the capacity of an air handler and based on the VFD speed and the flow going through it and the capacity, can I identify that one of your compressors is out before you know it? Now, it may be 55 degrees, it's meeting set point, everything looks great, but you have a compressor out, or you have a compressor that's going out. Maybe you status on both compressors and you're like, it's working fine, but you're 20% down on capacity from the previous day under these exact conditions. So there's a problem here. And those are the problems that we try to dig in and get to with our customers is there's going to be something that's happening here soon. You need to go check it out. When you look at buildings and how they operate today and you look at like why the three pillars, right? IEQ, comfort, and energy. Those are the three pillars we built the product around. And we have them staggered, obviously, like IEQ first, comfort second, energy third. So, IEQ overrides everything followed by comfort. When you look at like what are the problems caused by that don't allow you to achieve those three pillars, what you start to learn is like 70% software and 30% hardware. And we looked at that across millions of square feet, and that ratio is never broken down, unless sometimes it goes up to like 80 or 90% hardware, or 80, 90% software and 10% hardware. And so it's a very interesting ratio of, yes, things need to get fixed in the buildings, but oftentimes it's the software that needs to get fixed first.
Yeah.
Not discounting the fact, though, that, with what we do, we can get in during an audit phase of a building for a new customer, and we can tell them, like, hey, and we did it for one, they had a huge economizer wall, and we're like, it's not working. And it was because they did a pneumatic retrofit and forgot to retrofit it was literally like a barn door sized economizer in a 200,000 square foot building, one air handler. And so we quantified it for them. You're probably losing in the upwards of, I think it was like $300 or $400 a month. And that's seasonal, obviously. And so we help them work up a payback period. Even as part of our service, we help them review proposals on that to ensure that they got the work done correctly. So yeah, it's full end-to-end support of property management and asset management from an engineering perspective.
So do you deploy it like a tune-up first and then, let the software take control after that? Okay.
Yeah. I mean, when we generate significant returns from the software, right? So if 80% of all your energy issues or 70% or whatever are contained in the software, there's significant upside there. We have very low payback on our product. We have very good payback month over month on the SaaS fee, like extremely good in terms of CRE. But, when you look at like the why, right? I think that's what the most interesting thing is like we identified this air handler in the Bay Area. We were working on a project identifying an air handler, good size air handler, 100,000 CFM air handler. And it had these old blades that basically regulated the pressure. So it didn't have a VFD. And so the mechanical contractor, the one that we worked with in the building, recommended they put VFDs on it and gave them the cost. And so they brought the cost to us and said, like, what's the payback? Well, our system is running analytics real time on that unit saying, hey, it's overpressurized, and this is how much money you would save if it wasn't overpressurized. Well, we can't control the overpressurization. We're doing our best with the software. And so there's this savings that's left over. And what we ended up finding was it was an 18 or 19-year-old unit. Based on the runtime and the conditions of the unit, it only had about 4 years of life in it, and it was a 5-year payback on the VFD. Because the unit didn't really need to do that much. And so we went back to the owner and we're like, save your money, go spend on a brand new unit. Mm-hmm. And everybody just looked at us and they're like, you never do that. Like that's, like, why would you do that? Yeah, VFDs have the best payback. And you look at it and you say, like, not in this instance, no. So we provide that level of financial detail down to our customers too, so that they can make it really qualified. Like, it's not, you've hit 200,000 miles in your car and your drivetrain's gone. That's what our industry is used to. It's quantifiable evidence as to why or why not you should invest in HVAC.
Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview.
I want to circle back to a couple of the things you've talked about so far and kind of demystify them, and mostly around the machine learning aspect of this. So can you start by just saying, what does machine learning mean in this context? And maybe start also with, you mentioned digital twin, and I feel like starting with a digital twin is the first piece of this. What do you mean by digital twin? And then how does machine learning interact with digital twin? These are like the two buzzwords of the decade in smart buildings, but I feel like you can demystify both of them. What you mean here?
It sucks that we even had to like start using the term digital twin, because like everybody else is using it. Like we used to call them models. They're equipment models. We still call them models internally, but
I'm stuck on models. I'm going on models until the day I die. I'm not going to go towards digital twin.
It makes a lot of sense. It's like, I guess in some context, yes, it is a digital twin, but like, I'm not a huge fan of buzzwords, and I usually try and stay clear of a lot of ways, because buzzwords is marketing dollars. That's all it relates to. Who has the most marketing dollars wins the buzzword. But the real value, it's like, where's the value? I think when we look at digital twins, it's a combination of alarms and machine learning models that point to the best operation of a piece, the ideal operation. So if you look at the machine learning models that we have that make up our digital twin, we may have around 6 or 7 in a VAV, for example. So VAV is just a damper and a valve. At the end of the day, it's a damper and a valve and some sensors, right? We may have 6 or 7 that surround that VAV, and we deploy them to either forecast a condition that's going to happen so that we can react to it ahead of time, or we use it to optimize to a condition that we know is the most efficient possible. The third way we use them is for alarming, to say in a mechanical sense, I can't do anything here. I can't optimize how a damper reacts. It's just reacting. It's just controlling to one outcome. But what I can say is it controlling properly to that outcome? So I can use it in a reactive sense as well. So I can use it in a forecasting sense. I can use it in a control sense to optimize, and I can use it in a reactive sense to say, are you doing what I thought you should be doing? So you can use it actually to police itself. And that is our digital twin. It's actually self-policing. The only way ours started was that we started on an analytics platform, right? So we had already built like digital twins 5 years ago and optimized them. We correlated them to cost. We built the financial infrastructure we needed to say yes or no on should I replace it or repair it or upgrade it. We built a lot of those things into the platform before we even started down the road of control using machine learning.
So let me try to repeat that back to you. So you're taking a piece of equipment, and then you're taking the systems that's basically system of a bunch of equipment that's networked together, basically. So you have these system of systems. So you're creating a model of each of those systems and how they operate. And then the machine learning is basically saying, here's how it could be operating, should be operating, or here's a problem with the way it's operating.
Might operate even, it might even operate in the future. Like what are we looking at when it comes to the future of, this piece of equipment? You remember HVAC is extremely reactive in nature, which is also one of the reasons why you drive up energy. For all the, all the naysayers to machine learning, it's like, it may be the best reactive software you can write, but it's still reactive. What if you could write forecasted software of what it should be doing or going to do, not currently doing? So you take the data of what it's doing and you forecast what it should be doing. You start doing that ahead of time. And you can see these just drastic changes in, it's like flatlining. I think that was one of the most interesting things that, when I reached out to a few of my colleagues to let them review our data, and I was like the energy flatline. Like you don't see like these crazy peaks and valleys, and like it's so stable. And I think that those are the outcomes, because when you're forecasting ahead, you're not always reacting to the situation, and you don't have really wavy, dramatic data, which leads to less KW savings too. The demand is something that we're starting to get into now. If you look at even like demand is like that's demand, and demand is a result of reactive control. Got it.
Okay. I want to throw you a curveball here and talk about pricing, not for you to reveal the pricing of the product or anything like that. I'm not asking for a proposal, but I'm wondering the average, you guys primarily target CRE type of customers, right? So I'm thinking about the average, like transactional building, I'm going to sell this thing in a couple of years. How do they think about payback of this product? Because I feel like they're not sitting here going, man, I really need a SaaS tool to help my control system work better. You know what I mean? So how do they think about the ROI of a product like this?
I think in a lot of cases, it's a different decision maker that we've appealed to over time with Hank. And we go to asset managers and building owners. We work with everyone else in the supply chain, your BMS contractor, HVAC contractor, mechanical engineers, design engineers, property managers, building engineers. We work with everybody across the entire supply chain to provide value, but we sell to the building owner. So it is a pretty cut and dry situation. It's a financial decision. And a lot of times it's an OpEx decision, not a CapEx, which is what the industry is used to. And I think that's one of the challenges that building automation will now continue to have. It'll be very impacted by solutions like this they're always looking at CapEx. It's always a CapEx solution, and we're looking at an OpEx solution now. That's what SaaS is. And I think that, looking at the industry from that angle changes a lot, and especially a lot for owners who are looking at quarterly financials. They're saying, can this pay back in the same quarter? And the answer is absolutely. I can make you go cash flow positive with this solution in a quarter. That's unprecedented. Like lighting has a 6-month payback. That's a 2 to 3 quarter payback before you start seeing cash flow, right? And that's like the biggest no-brainer, black and white, should do solution still. And we can beat that by an entire quarter.
Okay. So it's a pretty easy, it's not about increasing NOI, or it's not about decreasing NOI and then trying to justify that with increased comfort or whatever. It's just positive NOI to begin with. That's the argument.
And then you add on, you start to compound the intangibles of better comfort. So your engineering staff can do more. They can actually fix the equipment that they want to now. They're not as focused on comfort all the time. Indoor air quality, give your tenants peace of mind that we're exceeding the ASHRAE standard for Title 24 in most cases by 30 to 50%. That's exceeding. When we walk into buildings, most of the time they're 20 or 30% below the standard right now.
Yeah.
So that's like a 60% improvement overall. It's significant. And so you look at some of the intangibles, and I think it gets very interesting. You even look at equipment degradation, $5 to $7 per square foot for HVAC costs for complete, replacement asset value. Energy savings. If I go save 30% energy on your HVAC, I reduce its consumption by 30%. I've subsequently reduced the wear and tear by 30%. Now all of a sudden you're looking at like RAV improvements and what do I get out of that? And it's still kind of an intangible, but I think it's going to become more prevalent as time goes on. Yeah.
And what happens in a situation like this when the savings aren't there? Like, we've all been to the building where it's like, it looks like there's going to be savings here. And then you get to the point where it's like, oh, there's just this reason or that reason why it's just not going to happen. What do you do then as far as the ROI?
Yeah, that's been like the interesting question since leaving California and progressing. So last year was our first time that we went nationwide. We've never been to a lot of the buildings. So it's also a first, I think, proving grounds that we're doing in a technical sense, building automation 2,000 miles away, 3,000 miles away. And we've never stepped foot in those buildings, and some of them are wildly successful. But it was also the first time where we saw energy prices as low as like 5 cents a kWh.
Yeah.
California averaged 9, 10, 15, 20 in the Bay Area. It's crazy. And all of a sudden we saw 5 cents. And that's where that's where the intangibles have to become tangible now. That's where you have to look at and say, look, I only have one engineer in the building. He's running around with his hair on fire. I really need 2 or 3, but I can't hire him. And it happens. I can't hire him. What about comfort? You look at comfort, and if the building's running, out of shape, then comfort's out of shape and indoor air quality is out of shape. It's not just one thing that you can point to those intangibles. You can also look at what's the age of the control system. Are you getting pressure to upgrade your control system for security purposes or whatever the reasoning is today as to why you would upgrade a system? And we can usually work around those issues as well, where like instead of upgrading, you just go with us. We'll hide, put everything behind a VPN, secure connection. You can have access via normal dashboard on the web. You don't have to worry about some crazy IP address that points to a Comcast router in your building anymore. This is more traditional SaaS. So I think that those intangibles we have sold around not having payback. Most of the time, the product goes cash flow neutral. So then you're just looking at like, what are those intangibles? Are they enough for a buying decision?
Got it. Yeah, I think more and more buying decisions are headed that way to start quantifying those intangibles. But it's definitely not evenly distributed. It's one of those questions that it's like, it depends on where you're at and what type of business it is and what type of building it is and all that. So Cool.
And
So
even in the understanding of like the asset manager,
yeah, absolutely. So let's zoom out to JLL for a minute. So how does your company that got acquired fit into what JLL is trying to accomplish?
Yeah, I think that was like a big part of our acquisition is like, where are we going to land? I think at the end of the day, we knew we were like an acquisition-based exit for us. Like we knew we were going to get acquired, but we wanted to make sure we landed in a spot that made the most sense, that we could expand and really gain market share. When we were approached by JLL Technologies, in my eyes, it was like the Google of prop tech, was the master vision. And the master vision being, we have all these disparate tool sets in the industry right now. And what we're trying to do is build an umbrella to house them under, so that there's a lot more interconnectivity. And that's what we want you guys to be. You guys can be the sustainability piece. We obviously have huge sustainability goals. We want to get, net zero by 2040. We really want to push on the sustainability picture, because there's a huge opportunity here. And we've seen it, right? We saw it firsthand. And it was like, you're right. But what about the technology play? We're so used to in like commercial real estate of like, how is a software only solution going to drive within the JLL portfolio? And I think that's where we got really hooked into JLL Technologies, was that we could see the end game. It's definitely there of there needs to be a Google. There needs to be more software. I mean, Microsoft, all these guys in the 90s came about for a reason, is because they found a way to house those solutions and be one unified platform.
Mm-hmm. Yeah, I like that umbrella term. Yeah, stitching all these different products together, because in the end, like you said, when someone wants to buy decarbonization, they don't want to buy advanced supervisory control plus FDD plus independent data layer plus all the acronyms we love on this podcast. People don't necessarily want to buy those things.
They don't understand them. Yeah, that's the other side. Is it's very hard to understand them.
Totally. I don't know what that means about this podcast then, if that's all those are the things we talk about. But we're obviously not just talking about those things. We're talking about enabling these outcomes. So
yeah. I mean, at the end of the day, like a lot of the acronyms, even back then, still played a role, right? A lot of the things that you did still have to play a role. Like there's still have to be interoperability in buildings. There's still have to be these things for an umbrella to exist. But it's the why. Like, why should an umbrella exist in this industry? And I think there's a very good why now. Whereas before, it may have been a little bit harder to establish the why. I think the why is pretty obvious. The reluctance to change is still there, but I think that it'll supersede that reluctance in the payback, the definite benefits of it.
Yeah, it makes perfect sense. Okay, back on the product a little bit more. I want to talk about in our foundations course, which is like all on my mind right now because we're going through it with 56 people right now, and it's like very, very intense for all of them that are learning about smart buildings for the first time. So the first thing they think about is who, right? Who does this impact, this new technology? And so I'd love to sort of dive into this a little bit, because I think it's interesting that the product is named Hank. It's named a person's name, and yet it's a software product, and it impacts a certain who, which is a building engineer, a building operator, like that user persona. So I'm wondering, and throughout this conversation, you've been talking about alarms and the ability for this person to get alerts about how their building's operating and opportunities. So I guess where I want to start with that is like, is that the primary user of the software? Because when you have this supervisory control layer, machine learning layer, typically you talk about it not needing users, like it's supposed to automate stuff. But what you guys have is like almost like an analytics platform also. So you have something that the building operator can log into, and they're, what's their sort of role in making the software successful?
Yeah, I think, even where the name was born from, when we got into our first building, it was a privately owned building, it was 100,000 square foot privately owned building. And they gave us like a pop-up in one of the open suites, and it was like concrete suite. We popped up a table and we sat there and we were running the building, and people would come by and they'd talk to us and they'd say like, what do you guys do? Like, you guys are the HVAC people doing the HVAC thing. And I brought my whole staff out. So it was like 5 of us at the time sitting in this pop-up because we wanted to see and feel and experience it. Like, what does this thing actually do? How does it actually feel? Like, and they come by and they say, hey, I feel more comfortable. And that's when we kind of stumbled across the comfort picture, comfort equation during, the grant period was like, we can actually improve comfort. Like, that was never even part of the equation. This can improve comfort. But then you started asking questions like, what is it? We started calling it a virtual engineer because they didn't have an engineer in that building. They had a floating engineer that would come around every now and then, but they didn't have an engineer. And it's like, and they said, what's its name? And so I just Googled the top 10 most trusted names, and Hank was like 7. And I was like, how about Hank? Like we'll go with Hank. And people loved it, and so we went from like a CIA spinoff name to like Hank, and it worked out really well. And I think, when we look at, like, you're absolutely right. The end user here is a building engineer. And when we look at all these different flavors of dashboards that building engineers have access to, it's expansive. And then all the knobs that they can turn in on these dashboards is even crazier. How many different set points do I have to control? And what does it actually mean? Why would I do this or that during the day? And we've tried to consolidate it as much as we can, like literal comfort sliders. You can actually go into Hank and just set the comfort. And when you set the comfort, you can see how it impacts energy. And you can say, wow, if I increase comfort here by 10% or 20%, I'm going to decrease energy by 5% or 6%. I can actually know, we can make it relative. It's a relative platform now that is pointed towards the outcome that they want. That is a challenge though, right? Because you're going from being able or wanting to or just historically changing all the knobs to that's being done already. Now you can focus on, like, hey, we have like 20 things that are broken and they require a lot of hands-on intensive labor that's very specific, right? Like shimming motors or finding out why compressors aren't working to their total capacity. There's these really advanced mechanical issues. And that's where we really work with building engineers on, is you don't have to sit behind a console staring and turning knobs all day anymore. Instead, you can really focus on the things that you're really good at, and we can get you out there and working on those things more to improve the building. We can also help you with payback analysis. Like we can actually get you a budget or help you get a budget and get that piece of equipment fixed or get it repaired. And we can be an advocate with the owner with you because they're the ones that put us in the building. Mm-hmm. And so I think in a lot of ways, our head of sales, and I'll take it from him, but he coined the assistant to the assistant engineer. This is giving you the ability to do better at your job. It's extending your capabilities drastically. And I mean, the flip side of the equation is, we all know what's going on in the trades right now, is they're hurting pretty badly. And building engineering is no exception. I graduated school with a lot of building engineers, and even they're saying it is like, there's just no more showing up. The baby boomers are retiring. Nobody's here to replace them. So they're being stretched. Budgets are being stretched. Owners don't want to spend money on an HVAC unit. What does that do? It's like an insurance policy, and we can help them out with those.
Got it. How about, that's a great answer. I think that's where it has to be headed, which is get these manual tasks off their plate, get these things that they shouldn't be doing off their plate so they can actually do the things that are higher value. What about the engineers that feel like they need to keep the manual stuff? And let me give you an example. Mm-hmm. This building I worked with probably 5 to 7 years ago, there was this guy, and he just really felt like it was his job to decide when the HVAC was going to turn on in the morning. I don't know why he felt that way, but there's a lot of buildings like that out there that like they view it as their job to show up in the morning and turn stuff on. How do you sort of overcome that inevitable skepticism or pushback around giving control to the AI?
Yeah. One of my buddies is the chief engineer down in San Francisco. He said when he was assistant chief, he floated around to a few different buildings. He went to a building, and the chief engineer, every day he would go, he had an hour lunch. He liked to work out. He'd change into his gym clothes. He'd run upstairs. He'd flip the chiller off, and he'd go to lunch. And then when he'd come back, he'd flip it back on. And he's like, why do you do that? And he's like, I noticed that when I used to leave, it would run for half an hour for no reason. And so I started saving energy, and I'd flip it off. And he was like, all right, like, it's just a different mentality, and I think it's that mentality is like, you have to, like, everybody is afforded a significant level of control. It is their building. Their job is to run the comfort and the HVAC equipment to comfort. Like we're trying to achieve the same outcome, but the HVAC is still their job every day. They're being judged on it. Their whole career is built on, does the HVAC work properly or does it not? So you can understand that there's a significant level of, there should be, right? Somebody came in and they said like, hey, I'm going to take over your whole job. And when it comes to this part of your job, I'm going to take this part of your job and you have to trust in me. I would say there should be a lot of skepticism. What we do is we try to get them involved early and often. It's still their building. They're still running the building. We need to know the nuances of the building. Like, what are those nuances? What's that floor that you just don't like? Which one is that? It's always this floor. It's always this piece of equipment. It never works. Like, great, let's tackle that one first. And we come up with we call it an onboarding plan, but it's a strategic plan to work with the on-site staff to ensure that it's onboarded in a way that makes sense with their current workflow. We train them on the software. We get them very integrated because they're an integral part of us being successful in the building. You can't just walk into a building, grab whatever mechanical drawings they have, grab the building automation and say, like, let's go to work. Inevitably, there's 30% of things that you're going to have to guess on. And if you guess wrong, you're going to cause more complaints and more harm than good.
Yeah.
We learned this very early on. And so, like, we are providing a service that helps them and helps the owner and helps the property manager. You know, the three people running the building or managing the building in that instance. And we have to ensure that it is going to help everybody. And so there's a big focus on our service in the beginning of alignment with the on-site staff. When it comes to the platform itself, they have the exact same overrides they have today. You want to override duct side pressure, go for it. You want to override the VFD, go for it. If you feel there's a certain scenario where this needs to happen, sure. If you do better, then we won't get an alarm. If something happens that goes wrong and we get an alarm and it comes back to our support staff, we may call you and talk you through it. Why'd you do that? Why did you feel like you needed to? Like, where can we come to a common ground? What can we do better? You know, we are, in every term of it, like a virtual engineering staff that's there to support everybody.
Mm-hmm. Cool. How about, we talked about who, and that would be one who. There's another who that's often involved, has their hands in the pot here, which is like a service provider, some control system that we've played that role before. There's a technician that's responsible for showing up here once a month and doing PMs and keeping that building automation system running. So obviously we interject this virtual engineering team, we interject this overlay software. How can you kind of bring those teams along in a new change like this?
I mean, John Dell found a way to survive with Windows, and he was wildly successful. He recognized the change in the industry and he adapted very fast, faster than anybody else could. And that's why we all still use Dells. I think that there's a certain adaptation that will have to happen. Virtual engineering is an inevitability. It's not it may happen. There may be a breakup of this vertically integrated stack, this monolithic stack that everybody owns. It will happen, and I think understanding that, we're not a hardware company. We are a software company. If I go find a broken controller, a broken sensor, there's one endpoint per 1,000 square feet, and there's 3 associated sensors to that. So there's 3 sensors associated per 1,000 square feet. I'm not providing those. I'm not replacing those. That's still entirely your system. If it's an Allerton building or a Siemens building or Johnson building, it's still their system. No intention of replacing components. That's not my business. I'm just trying to make it all work better. So when I go find, just like a building engineer would, when I go find a broken sensor, a broken controller, or an opportunity to balance a system, I put it out there. Hey, you should balance the system. This is why. This is what it's going to do for you. And you should probably go use X, who's going to be the guy there, path least resistant. So in a lot of ways, again, I'm just providing a virtual engineering service. I'm not ruling out or changing, a lot of what the industry is used to, which is the hardware side. So I'd say the services are going to change in some ways. We are running the software in the building now. There is no need to do software maintenance or software upgrades or a lot of those things. But there still is tons of improvement. I mean, on average, we find 10% of all controllers are failed in the building and nobody knows. That's a $5,000 to $10,000 project just waiting in the wind on every building that we get into. It's just the understanding of where the industry is going and where can I drive value in this kind of like new market or evolution of the market that we're in.
So do you see a reduced need for controls service contracts then? What are you thinking there?
Yeah. I think that, control service contracts are for the exact reason that we talked about before, which is, the skepticism, right? The skepticism is you have to have control service contracts right now because you have to be able to change the software seasonally. Inevitability, right? Right now, that is entirely an inevitability. Like you will have to change it seasonally. It will not operate cross seasonally unless it's operated inefficiently. Mm-hmm. You can run everything at maximum cooling and heating, and I'm sure it'll survive seasonally. If you want to operate it to its utmost efficiency, that's not plausible. But, in a lot of ways, I think that that's where the industry is geared, is a lot of those kind of software-driven changes during these service contracts. And I don't think that, under our control, those aren't necessary. But that's not to say that things don't break, customers don't know. I mean, one of the funniest things, we get like supplier temp sensors, which in a zone, and everybody goes like, oh, that's a monitoring thing. And it's like, no, it's a controls thing. We use it for control purposes. It's actually a very, very valuable set point in terms of machine learning and forecasting. It's almost one of the most valuable set points that we have in the system. And we find that 20 of them are broken. We'll tell owners they have to go replace those. Like, you want this level of comfort, we need those replaced. That's a project, There's plenty of projects to be found. It's just, that's the hardware side of the business, and this is the software. So if you're able to divide those and figure out what service needs to be had here, then that is still where the service belongs.
Yeah. Cool. All right. Well, thanks, Zach. This has been fun. Let's end with Carveouts. I'd love to hear a book, podcast, TV show, whatever you want to share with the audience and recommend that they check out. It could be personal or professional life.
Yeah, the book Blue Ocean was the book. I talked a lot about category creation. It was pretty fantastic when we read it for our business to understand a lot of the things I'm talking about, like virtual engineering and where this goes, was derived from the necessity to create a new category. This is the evolution of building automation. And everybody talks about that, but it's siloed. It's so disparate of like, we're going to evolve the UI. We're going to evolve, optimization. And it's like, you're missing all the core components though, which is value delivery to the end users, these three pillars of people that run and manage buildings. And so I think that was like the biggest thing, is like this all-encompassing category that we've created, which is virtual engineering. And then creating the connotation around that. It's a very positive thing for everybody. It can be perceived as scary, but it's also like creating the messaging. And a lot of that was derived from, a lot of the big things they talk about in Blue Ocean.
Cool. Yeah, I think we need a lot more of that sort of thinking. I haven't read that book, but I'm thinking about picking it up now. I'll share mine. So this is one of my favorite books. So you said that's your favorite books. It's called A Guide to the Good Life, which is, it sounds really gimmicky and it sounds like self-helpy, but it's really not. It's like an introduction to Stoicism, which is a 2,000-year philosophy that came from the ancient world, basically. So this is just like modern day explanation of that philosophy, and I think it's really great for really just managing the day-to-day BS that we all have to deal with, mostly in our own minds, and just kind of being happier people. So we'll share that one in the show notes as well. I definitely recommend people check it out. So
yeah, that's good.
Cool. Well, thanks, Zach. We'll check out Blue Ocean. We'll put that in the show notes, and we'll link to everything we talked about as well with Hank and JLL and all that stuff too. So thanks for coming on the show.
Awesome. Yeah, much appreciated, James. Thank you.
All right, friends, thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.